Hey everyone, and welcome to a special science quiz challenge. We're going to test your knowledge on everything from electricity to energy and even wheels. Think you're ready? Let's dive right in.
Okay, so here's the deal. I'm going to throw a question your way, give you a few seconds to think it over, and then boom, we'll go through the answer together. Sound good? Awesome. Let's get this show on the road with round one, electric energy.
All right, first question's up. So what exactly is the function of a cell, and what is a battery? Okay, you got an answer? A cell is like a tiny power plant, a single unit that turns chemical energy into electricity. And a battery? Well, that's just when you link more than one cell together to get even more power.
Okay, next question. This one is super important for understanding circuits. What is the direction of energy flow in a circuit? Time's up. So energy always flows out from the positive side, goes all the way through the circuit, powering up, say, a light bulb, and then comes back to the negative side. It's got to be a complete loop or nothing happens.
So we've talked about cells, but there are different kinds, right? What's the main difference between a non-rechargeable cell and a rechargeable one? Okay, you ready? It really comes down to this. Non-rechargeable cells are a one-and-done deal. Think of the batteries in your remote. Once their power is used up, that's it. But rechargeable ones, like in your phone, are amazing because you can reverse the chemical process and charge them up again and again.
I've said the word circuit a couple of times now, but what is a circuit really? It's actually pretty simple. Think of it like a racetrack for electricity. A circuit is just a complete, unbroken path that electricity flows along. If there's any break in that path, the race stops and everything just shuts down.
All right, sticking with circuits. Can you name the 4 essential parts of a simple circuit? Let's see how you did. First, you need an energy source, like a battery. Second, you need a conductor, like a wire to carry the electricity. Third, you've got to have a device, like a light bulb, that actually uses the power. And finally, you need a switch to open and close the circuit, basically turning it on and off.
Okay, let's zoom out a bit, from a tiny circuit to a massive one. What is the national grid, and how does all that power actually get to your house? It's really just a giant circuit for the whole country. It starts at a huge power station, travels across those big power pylons you see everywhere, goes through substations to get the voltage right, and then it finally arrives at the outlets in your home. Pretty cool, huh? Now, a lot of those power stations run on coal. So can you think of one good thing and one really bad thing about using coal for power? Let's break it down. The big advantage? It's cheap. That's really the main reason it's been used for so long. But the disadvantage is a huge one. It causes a ton of pollution, and it's non-renewable. That means when we run out, there's no more to find. So, if coal has those problems, what are some better options? Can you name 2 examples of green or clean energy sources? There are some awesome alternatives out there. We've got solar power from the sun, wind power from those giant turbines, and even hydropower that uses the force of moving water. All much cleaner.
And that's the end of round one. You're doing great. Now let's get ready for round two. We're going to talk about safety and stored power.
Okay, round 2 starts now. Let's talk about materials. Can you give me an example of a conductor and an example of an insulator? Got 'em? Awesome. Conductors, like metal and water, let electricity zip right through them. But insulators, like rubber and plastic, stop electricity in its tracks. That's why wires are covered in plastic. It keeps us safe.
Okay, this next one is so important. It's a safety question. If you see someone getting an electric shock, what is the very first thing you should do? This is absolutely critical. The first thing you do is turn off the main power source immediately. Do not, under any circumstances, touch the person because the electricity can travel through them to you. All right, let's change topics just a little. What is stored energy? You might also hear it called potential energy. And can you give me an example? Did you get one? Stored energy is just that, energy that's being held, waiting to be used. Think about a stretched out rubber band or a jack-in-the-box all wound up. That's stored energy right there. Okay, so you've got that stretched rubber band. What happens to all that stored energy the second you let it go? It changes. All that stored energy transforms into movement energy. It goes from potential to kinetic, and that's what makes the rubber band go flying. Back to batteries for a second. Why can some of the newer ones, like the battery in your phone, actually be kind of dangerous? It's all about what they're made of. Those lithium-ion batteries are packed with stuff that's really flammable. So if they get damaged or too hot, they can be a real fire risk. You've got to handle them carefully.
Wow, you are cruising through this quiz. 2 rounds down, 1 to go. Let's finish strong with our final round all about wheels and axles.
All right, final round. Let's go. First up, what's the whole point of a wheel and axle, and what's the name for that center point it spins around? It's one of the most brilliant, simple machines ever. Its job is to make things move easier. You have the wheel, and it turns around a pole in the middle called the axle. And that center spot, we call that the pivot point.
Ooh, a 3-part history question for you now. Who invented spoked wheels, why were they better, and when did we get air-filled tires? Okay, let's travel back in time. Way back around 2000 BC, it was the Egyptians who came up with spoked wheels. They were a game changer because they were way lighter and faster. Now, fast forward to 1888. That's when the first pneumatic, or air-filled tire showed up on a bike, making rides a lot less pumpy.
Okay, turns out not all axles are created equal. So what's the difference between a rotating axle and a fixed one? With the rotating axle, the axle and the wheels are basically one solid piece that spins together. This makes turning really hard. But with a fixed axle, like on your bike, the axle stays put and the wheels spin around it. That makes steering way, way easier.
Here's another word we've been using: system. What does that word actually mean in science? A system is just a bunch of different parts that all have to work together to get something done. A bike is a great example. It's a whole system of parts: wheels, gears, brakes, and they all have to cooperate to make it go.
We mentioned that rotating axles are tough to turn, but what's the real problem that makes them so tricky? The biggest issue is that both wheels have to spin at the exact same speed. Think about when you turn a corner. The outside wheel has to go a longer distance than the inside one, right? Well, a rotating axle doesn't let that happen easily, which makes it super hard to steer and can even make the vehicle tip over.
Here we are, the final question of the whole quiz. Why is it so important to get rid of old batteries the right way? This is a big one. You can't just toss batteries in the normal garbage. They're filled with some nasty chemicals, and if they end up in a landfill, that stuff can leak into the ground and pollute our environment.
And that's a wrap. You did it. You made it through the entire science challenge. Great job, seriously. You should be super proud of yourselves.
So before we go, I want to leave you with a little something to think about. Just look around the room you're in right now. What's an object you can see that has a really cool system of parts all working together? Keep that curiosity going. Thanks so much for playing along today.